Hello everyone, I am Soham Panthi.
And I'm Karan Bhakuni.
We will be presenting a computer vision project on low light blurred image enhancement. So in our project, we have utilized four algorithms for low light image enhancement, namely histogram equalization, KS algorithm, parameter tuning, and nature inspired algorithm. We also have done image deblurring. So for image deblurring, we have used sharpening kernel, Fourier transform, winner filter, and the use of CNN. So we have compiled the dataset consisting of 1,000 images captured during nighttime in our IIT Jodhpur campus. All the algorithms have been tested on this dataset. Now, Karan will walk us through the GitHub profile.
So we have uploaded our code on our GitHub profile. So these are all the files. Then these are all the project details mentioned here. Now we have also uploaded our results of the project. These are the results. Now we will going to explain each and every code in detail.
Now, let me explain the algorithm for histogram equalization. In this code, first we'll import the necessary libraries like OpenCV, NumPy, Matplotlib, OS, and TQDM. So now first we'll set the folder path variable to the folder that will contain the images. Next, we'll get the list of images with having extension like PNG, JPG, or JPG or BMP. Then we'll define the main function, that is night image, that will enhance the night images. First, we'll set up the TQDM progress bar that we with a total number of images. Then we'll loop through the image files in the folder using the for loop. First, we'll read the image using OpenCV inbuilt function IMRead. Then we'll resize the image. Then we'll define the kernel matrix for sharpening the image. After that, use the bilateral filter to remove the noise from the image. Next, we'll use the uh, Gaussian blur to the image using inbuilt Gaussian blur function in the OpenCV. Next, we'll combine the original image and Gaussian blur image with using add weighted function. Now we will define the brightness and contrast matrix. Next, we will increase the brightness of the image using cv2.add function. Then change the contrast of the image. Then we will be doing histogram equalization. For that, we'll define the new function. Then apply this function. Apply the function on contrast and brightness corrected images. Then we'll calculate the difference between original image and the contrast bright corrected image. So we have then we'll combine the difference image and the original image using add function. Then convert this image to the grayscale using CBT color function that is inbuilt in the OpenCV. Then apply the adaptive threshold to create the binary image using adaptive threshold function. Then invert the binary image using bitwise not function. Then apply the mask to set the shadow areas to fix the values, for example like white using the add function. And now again we'll invert the image because we want the original image. First we have inverted image, then we have some perform some operations, again we are inverting the image. Lastly, convert the image from BGR to HSV scale for increasing the saturation. We are increasing the saturation of the image by factor 1.7, which is shown here. Then converting image back from HSV space to original color space, RGB, BGR color space. Then writing the enhanced image in the given folder location. Then use OS to write the cv2.write to write the processed image into the folder. Then finally updating the progress bar, and finally giving the function call that will execute the above defined function. Now let me explain the algorithm for histogram equalization. In this code, first we'll import the necessary libraries like OpenCV, NumPy, Matplotlib, OS, and TQDM. So now first we'll set the folder path variable to the folder that will contain the images. Next, we'll get the list of images with having extension like PNG, JPG, or JPG or BMP. Then we'll define the main function, that is night image, that will enhance the night images. First, we'll set up the TQDM progress bar that we with a total number of images. Then we'll loop through the image files in the folder using the for loop. First, we'll read the image using OpenCV inbuilt function IMRead. Then we'll resize the image. Then we'll define the kernel matrix for sharpening the image. After that, use the bilateral filter to remove the noise from the image. Next, we'll use the uh, Gaussian blur to the image using inbuilt Gaussian blur function in the OpenCV. Next, we'll combine the original image and Gaussian blur image with using add weighted function. Now, we will define the brightness and contrast matrix. Next, we will increase the brightness of the image using cv2.add function. Then change the contrast of the image. Then we will be doing histogram equalization. For that, we'll define the new function. Then apply this function. Apply the function on contrast and brightness corrected images. Then we'll calculate the difference between original image and the contrast bright corrected image. So we have then we'll combine the difference image and the original image using add function. Then convert this image to the grayscale using CBT color function that is inbuilt in the OpenCV. Then apply the adaptive threshold to create the binary image using adaptive threshold function. Then invert the binary image using bitwise not function. Then apply the mask to set the shadow areas to fix the values, for example like white using the add function. And now again we'll invert the image because we want the original image. First we have inverted image, then we have some perform some operations, again we are inverting the image. Lastly, convert the image from BGR to HSV scale for increasing the saturation. We are increasing the saturation of the image by factor 1.7, which is shown here. Then converting image back from HSV space to original color space, RGB, BGR color space. Then writing the enhanced image in the given folder location. Then use OS to write the cv2.write to write the processed image into the folder. Then finally updating the progress bar, and finally giving the function call that will execute the above defined function. Now I will run the code to show you the output. Left side image shows the low light image, and right side image is the enhanced image by our algorithm. We have also written the image into local file. So if you go over here and if you click here, you will see the image. KS algorithm. First, we are going to import the necessary libraries like OpenCV, NumPy, skimage, matrices, OS, and TQDM. Then we are going to define our main function, namely name enhance image to enhance the input image. This function accepts the image in BGR color space. Now we are going to convert the image to HSV color space using cv2.cvt color function. Then we are going to normalize the V channel of HSV image by dividing it by 255. Now we are going to apply the proposed decomposition algorithm to separate the illumination and reflectance component of the image. Then we'll adjust the illumination of the image using normalize function to normalize the illumination component of the image. Now we'll multiply the adjustment illumination component with the reflectance component to get the enhanced V channel. Then we'll normalize the enhanced V channel by using normalize function again, and we convert it into unsigned integer data type. Then we are going to merge the enhanced V channel with H and S channels of input HSV image using the merge function. Then we'll convert the enhanced HSV image into BGR color space using CVT color function again, and return the results. Then we'll define the new function for calculating the PSNR value. PSNR is nothing but peak signal to noise ratio between two input images. The function accepts the two images. One image is the ground truth, and second image is the enhanced image in the NumPy format. Then we'll calculate the MSE, that is mean square error. If the images are identical, then return infinity as the PSNR. Else, calculate the PSNR using the formula. Formula is here. Then we'll define the path to the folder containing the input images. Oh. Now we are going to list the image files into folder extensions like PNG, JPG, or BMP. Then we have used TQDM function to show the progress bar. Then we'll loop through the images in the folder. Then then one by one we'll read the image, we'll resize them, and apply the image enhance function to input image to get enhanced image. Then we are going to save the enhanced image to the specified folder path. Finally, we are going to calculate the PSNR between the input image, that is ground truth, and the enhanced image using PSNR function and appending this result into the list and converting the input space into grayscale that is needed for calculating the SSMI. We are going to calculate SSMI. We have already imported the SSMI line here at the beginning, line number 4. Yes. So we are going to calculate the SSMI for the images and finally updating the process path. Now I will show you the output of the code. In the left hand side you can see the image which have very low light, and in the right hand side you can see the image which is enhanced by our KS algorithm. I'm going to explain you the next algorithm, that is night enhancement algorithm using parameter tuning. Here we are going to importing the main libraries as we have imported in the first two codes. Then we are going to define our main function, that is the sharp image. Then we are looping through the image files in the folder that are already we are linking one folder uh, where we have located all the images. Then loading the images using cv2.imread function. Then we are going to resize the image to 412 by 312 size using cv2.resize function. Then we are going to use the sharpening kernel with the numpy array. Then using the bilateral filter to remove the noise and preserve the edges. Then now we are going to apply the Gaussian blur to the image using Gaussian blur function. Now we will use the add weighted function to blend the original image and the blurred image to create the sharpened image. Now we are going to calculate the average pixel value for of the original image using np.mean function. We are going to calculate this average value because we are going to differentiate the images based on their intensities. If the image is very dark, then it will go into one loop. If it is medium dark, then it will go in another loop. And if it is bright as compared with the other images, then will do very less in image enhancement for that image. Then here is that logic that I have told you. It will go in the first loop if image is very dark. It will go into the second loop if it is medium dark, and so and in the last image, image has already very good light conditions. That's why we are not going to increase the brightness and other parameters of the image. Next, we are going to calculate the brightness of the image using cv2.add function and subtract function. Then adjusting the contrast of the using. Then we are going to calculate the absolute difference between the contrast adjusted image and the original input image. From this, we are going to create the sharp image by adding 3 times the absolute difference between the original image using cv2.add function and converting the image into HSV space using the inbuilt function. And also we are going to clip these values between 20 to 150 using np.clip function. Then we are going to convert image back into original color space. For removing the noise, we are using non-local means denoising using cv2 dot fast nl means denoising colored function. Now, and at the end, after removing the noise, the final image is ready. Now we are going to write the image into given folder, and uh, finally we are going to give the function call and show the image. Now I will show you the output of the code. Here you can see on the left hand side the image has very low light, and on the right hand side the image is enhanced by the parameter tuning algorithm. Next algorithm is night image enhancement by uh, nature inspired algorithm. So in this code also we are going to import the necessary libraries first, like OpenCV, NumPy and so on. And then we will jump directly to the main function, that is night nature. So in this function, as usual, we are going to import the images from the folder. Then we are going to loop through the all image files for reading the images and resizing the images. Now the main part is here. Here we are going to perform the nature inspired low light image enhancement on each channel. So cv2 dot create he creates the nature inspired low light algorithm object, and we are going to apply this on every channel, that is blue channel, green channel, and R channel. Then we are going to merge the enhanced channels back into RGB image using the merge function. After that, I am going to apply the gamma correction for additional image enhancement. Finally, we are going to save the image on the desired path, and we are going to update the status bar at the end, and we are going to show the image. And at the end, I will use the function call. Now I will run the code to show you the output. So on the left hand side, you can see that there is no light in the image. So nature inspired algorithm has enhanced the light, and which can be seen on the right hand side image. Also, the image is saved on the local desktop. You can see it here.
So now, as Soham has explained the programs for low light image enhancement, now we will go to the image deep learning part. Now for this, we are going to discuss the first algorithm, that is deep learn using Fourier transform. So in this, basically we are using a Fourier transform to deep blur the images. So first we will going to import the necessary libraries. Then we will going to read the image with the help of imread function. After that, we will apply a horizontal motion blur filter to the image by using a kernel of size 3 cross 3. So basically, this kernel is a horizontal line, and it will create a blurred version of the original image. Now, what we will do is compute the 2D Fourier transform of the blurred images using the inbuilt function of Python. Now we will create a filter in the Fourier domain that will just attenuate the frequencies corresponding to the blur. The filter is basically a mask that zeroes out a square region in the Fourier domain that that corresponds to the frequencies of the blur. So basically, we are removing the frequency that are corresponding to the blur part of the image. Now we will apply the filter to the Fourier transform of the blurred image. Now, after doing all of this, we will compute the inverse Fourier transform of the image to obtain the deblurred image. Then we will normalize the image to obtain a grayscale image with a value between 0 to 100. Then after that, we will calculate the mean squared error to get the value of the PSNR, that is peak signal to noise ratio, and SSIM, that is structure similarity index, between the ground truth and the blurred image to evaluate the performance of the algorithm. Now, at the end, we will go to show the result with the help of matplotlib library. Now I am going to show the output of this. So this is the output we are getting. On the left side, you can see that is the blurred image, and on the right side, you can see that is the deblurred image. So you can also see the value of PSNR and SSIM. But you can notice that the results are not so promising in this case. But wait till the end. Picture abhi baki hai. Now we are going to move on to the next deblurring method, that is sharpening kernel deblurring. So in this method, first we are going to import the necessary libraries. Then after reading the images, we will resize to this particular 312 into 312. Then we will apply box filter to it to remove some of the noise and blur from it. After doing that, we will also import the original image for further uses. And after that, we will declare the sharpen kernel to sharpen the image. After that, we will declare a function multi-convolver. In this function, we will use convol 2D to basically remove the blur by using the sharpening kernel. Then we will define the function convolver RGB, and first we will going to convert it from RGB space to YUV space, and then we will apply the multi-convolver function that is already declared above. Then we will convert again it to the RGB space and return the image. Next, we will define another function, that is convolver comparison. In this function, basically, first we will split it into RGB and use the multi-convolver function that is defined above to each of the channel, that is RGB, RG and B. Then we will stack the output of RGB and then return the final image. Then we will going to use this convolver comparison function and then get the sharpened image using the sharpening kernel. So after that we will define this PSNR to calculate the peak signal to noise ratio of the image. Then using the matplotlib library we are going to plot these results. Now I am going to show you the result of this algorithm. So now you can see that on the left hand side we have the blurred image, and on the right hand side we have the sharpened image using this sharpened kernel algorithm. And you can see that visually the results are very promising, and you can also note down the value of PSNR. So now we will going to discuss our next algorithm, that is Wiener deblurring. So first we will import the necessary libraries, then we will perform the deblurring using Wiener filter. So basically first we will define several functions including f inverse, preprocess, deblur and PSNR. So now the first function f takes an input value q and returns a nonlinear transformation that will be based on these parameters a and c that are mentioned there. If somehow a custom function is provided as an argument, then instead it will use the default transformation. Similarly, the function f inverse is just the inverse of this function f, and it returns the original value q based on the transformed value f and some parameter a and c. Then next we have this preprocess function. It will just normalize the input image between the pixel values to be between 0 and 1 and clips any value that is beyond these values. And it will use a variable epsilon that is very small to avoid any numerical issues. Then coming to the main function, that is the deblur function. So this function basically takes a blurred image, a kernel size, a divisor to create a point spread function. It then separates the input image into its RGB channel and applies the Wiener filter on each channel separately. Then it will combine the image into an RGB image. So after that we will use this PSNR function. This will calculate the peak signal to noise ratio between the two input images using mean squared error. So now we will going to see the result using the matplotlib library. So here you can see the results. So on the left side we have the blurred image, and on the right side we have the two sharpened images, and you can see the PSNR values as well.
Next algorithm we have used convolution neural network for deblurring the images. Here we have defined the model, CNN model. So CNN model defines the class which has name CNN, and that is inherited from PyTorch module class. The name module class provides the functionality for building neural network in the PyTorch. Then the CNN architecture consists of three main parts: the encoder, the adaptive kernel, and the decoder. The encoder takes an input image with three colored channels, that is red, green, blue, and applies two convolution layers, each with the kernel size of 3 by 3 and 32 channels and 64 output channels, respectively. Each convolution layer is followed by a RLU, that is rectified linear unit activation function. The adaptive kernel takes three output of the encoder and applies three convolution layers, each with the kernel size 3 by 3 and 64 output channels. Each convolution layer is also followed by ReLU activation function. Then the decoder takes output of adaptive kernel and applies two transpose convolution layers, each kernel size 3 by 3 and 32 and 3 output channels. Each transpose convolution layer is followed by then again ReLU activation function. Overall, this architecture is used for deblurring the image. Now I will show you the code to drive this function. So here first we have imported the necessary libraries. We are doing this using PyTorch. Here we are defining the number of epochs, how many epochs we are going to run for the model. So this is the image directory. Here the basic images are sharp images are saved. So this line is used to tell whether we are going to use the CPU or GPU for this. The next is batch size. Batch size we have kept as 4. Mm, Moving forward in the code, we have used this train test split for training and splitting the data. So this is inbuilt function uh, in the PyTorch, and we have kept test size as 25% and training size as 75%. Then we have created the class for different functions using dimsum functions. So here is the code you can see. Then the main part is this optimizer. We have used ADM optimizer. So here is the scheduler, and which can automatically changes the learning rate. So this function does that. Then we are going to fit the model and then validate the model, and finally we are going to save the model here for a future purpose. Now I will show you the output after running this deep learning model. So here you can see the results. So left hand is a blur image and right hand side is a deep blur image. We have taken batch size as 4, therefore we have 4 images here. So this is our flagship algorithm because SSM value is 0.97. So it is very good deep blurring the input images. And PSNR value is also 36.81, that is also considered as a good PSNR value. So this does the deep blurring task very well.
So now we have completed our project. So first we have enhanced the low light image, and then we have used the deep blurring algorithm to deep blur the images. For both the processes, we have used 4 algorithms, and the basic strategy is to first enhance the low light image and then deep blur the images. So and also we have also uploaded this code on this Git on our Git profile. So do visit our Git profile, and if you have any doubt or something, so you can just contact us through our Git page. So the link will also be provided in the description.
And guys, if you like the video, then give thumbs up. Please like the video, comment, and subscribe to our YouTube channel. Thank you.
Thank you.